Ratios are simply comparisons of two numbers. For example, the student-to-faculty ratio in Juan's math class was 40:1, meaning that there were 40 students to one professor. This can also be written as 40:1 using a colon in between, or it can also be written as a fraction, 40/1. In this example, we're supposed to write the ratio as a simplified fraction. With ratios, the ordering is very important. Since they mentioned 219 minutes first, that will go on the top, or the numerator of the fraction, and 183 will go in the denominator. Now we need to figure out how to simplify this, or even if it does simplify. Now, looking at this, 219, it's not obvious to me what divides it. And so I would just go ahead and start trying a few small numbers in my calculator. Obviously, 2 is not going to divide it because it's not an even number. But when you try 3, it turns out that 3 does divide 219, and it gives you 73. So 219 is 3 times 73. It also turns out that 3 divides 183, and you get 3 times 61. 73 and 61 are both prime numbers. But what we can do here is cancel the 3's. So now we're going to have 73 over 61. Let's do a self-check. Now I want you to take a careful look at this one before you work it out. Pause the video, work it out on your own, but look for a trap in there. Here we have 44 minutes to 4 hours. So the first thing that we need to notice is that we have minutes and hours, so our units don't match. We can't write the ratio until our units match. So let's take 4 hours and rewrite that as minutes. Well, to get that, we need to take and multiply that by 60, and that's going to give us the correct minutes, which is going to be 240 minutes. 44 was the first number in the ratio, and now we have 240 for the second number. Now, I can factor the top, or the numerator, as 4 times 11. And the denominator is also divisible by 4. I could write that as 4 times 60. So now I can cancel those 4's. That leaves me with 11 over 60. Now 11 is a prime number, and it does not divide 60, and so we can't simplify this any further. In this example, we're supposed to find the ratio of the shortest side of this triangle to the longest side. Now when we look at this, obviously 8.4 is going to be the shortest side and 18 is going to be the longest side. Now they told us to find the ratio of the shortest to the longest. That order matters. We're going to put the shortest first, or on top of the fraction. So we'll put 8.4, and then we're dividing that by 18. Now I don't like this mix of fractions and decimals, and I can get rid of that by multiplying top and bottom of this fraction by 10. So I have 8.4 over 18, and I'm going to multiply top and bottom by 10, and this is going to move the decimal place to the right by 1 on each of those. So 8.4 times 10 is going to be 84, and then 18 times 10 is going to be 180. Okay, so now that I have 84 over 180, I want to simplify this. Now, it might not be immediately apparent what divides these, except that I can see that they're both even. So one thing that I could do is just divide both of them by 2. And when I do that, 84 divided by 2 is going to be 42. And then 180 divided by 2 is going to be 90. Okay, so now I've simplified this to 42 over 90. Now I might notice again, these are both even. So I could divide them both again by 2. So this would give me 21, and this would give me 45. Now I have 21 over 45. These are a little bit smaller numbers. Maybe I remember that 21 is 3 times 7, and 45 is going to be, what, 5 times 9. And I can continue factoring that 9. So I have 3 times 7 over 5 times 3 times 3. All right, now I can cancel 2 3's. And what I have is 7 over 5 times 3. Those are all prime numbers. We don't have any common numbers between the top and the bottom. So we have 7 over 5 times 3, which is 15.